Bismillahirrahmanirrahim. Assalamu alaikum students. I hope you all are doing well. This is your chemistry lecture, and in today's topic we are going to learn about relative molecular mass and relative formula mass. In yesterday's lecture you people learned about the relative atomic mass, and I have told you that relative atomic mass can be deduced by using the carbon 12 isotopes. And how many isotopes of carbon are there? 3 isotopes: carbon 12, 13 and 14. But out of these 3 we are using carbon 12. So carbon 12 is taken as standard, and the atomic masses, actually the relative atomic masses of all the elements, are measured compared with the carbon. And not all the R values are whole numbers. Some are whole numbers, but some are not whole numbers. And why those values are not whole numbers? Because actually the mass, relative atomic mass of any element is the mixture of isotope. When we want to find out the relative atomic mass of some element, we are using the mixture of isotopes, because elements exist as mixtures of isotopes. And what are isotopes? Isotopes are having the same number of protons but different number of neutrons. Number of protons refers to atomic number, and proton plus neutron refers to nucleon number. ठीक है? Number of protons, atomic number. Proton plus neutron, nucleon number. So the relative atomic mass is thus calculated based on the relative percentages of the isotopes. What is the relative percentage of a specific isotope? We can find out the average atomic mass, the relative atomic mass. Let's say the isotopes of chlorine, Cl35 and Cl37. Most commonly you use 35, and the percentage of 35 is 75%, and for 37 it is 25%. So to find out the relative atomic masses, you will use these percentages of chlorine, and by doing calculations you will find out the relative atomic mass of chlorine, that is 35.5. Okay, we have discussed all this in a previous lecture. Today we'll discuss about relative molecular mass and relative formula mass. As I have told you already that the term relative molecular mass is used for covalent compounds. We use it for covalent compounds. And what is the symbol for relative molecular mass? It is Mr. M for molecular mass and R for relative molecular mass, right? So many elements and compounds such as nitrogen dioxide exist as molecules. What is the formula of nitrogen dioxide? NO2. And NO2 is an ionic compound or covalent? It is a covalent compound because it is formed by the sharing of electron. Covalent compounds are formed by the sharing of electrons, and ionic compounds are formed by the loss or gain of electrons. So compounds like chlorine, nitrogen dioxide are covalent compounds. So we'll use the term relative molecular mass for them, because these are covalent compounds. And the masses of molecular substances is measured in terms of its relative molecular mass, and the symbol is mR. ठीक है? And because it is ratio between two same quantities, two same values, so they have no units. Relative molecular mass has no unit. Some examples of relative molecular mass, how we can find the relative molecular mass. You can take the example of chlorine. You know that a molecule of chlorine is made up of two atoms of chlorine. When two atoms of chlorine will combine, one molecule of chlorine will be formed. This is molecule of chlorine, and the molecule of chlorine is a diatomic molecule because it has two atoms. So to find out the molecular mass of chlorine, you will use the atomic mass of chlorine atom and then multiply it with 2, because you are using two atoms of chlorine, right? You will get the answer. It is 71. Nitrogen dioxide is triatomic molecule. It has 3 atoms, 1 nitrogen and 2 oxygen. So 1 atom of nitrogen has atomic mass of 14 and 2 oxygen atoms have 32. 14 plus 32, you will get 46. Clear? This is how you will find out the molecular mass, relative molecular mass. It is calculated by adding together the relative atomic masses of all the atoms in its chemical formula. This is chemical formula, and all the atoms, you have to use the relative atomic mass of all the atoms that are present in this formula. Next is relative formula mass. Symbol for this is also mR, and we use the term relative formula mass for ionic compounds, because ionic compounds do not exist as molecule. The relative molecular mass of ionic compound is more accurately known as relative formula mass. And like relative molecular mass, formula mass is given by the symbol mR, and it has no units. Some of the examples of relative formula mass, some examples are like sodium chloride NaCl, calcium nitrate, CaNO3 twice, and copper 2 sulfate crystals, CuSO4.5H2O. Okay, let's first discuss about sodium chloride. The mass of one atom of sodium is 23, and as there is one atom of sodium, so you will use 23 plus, for chlorine it is 35.5, and you will get the formula mass, it's 58.5. For calcium nitrate, first you have to recognize the or identify the atoms of elements that are present in a compound. In this case, there are 3 elements: calcium, nitrogen, and oxygen. By using the periodic table, you know that the atomic mass of calcium is 40. For nitrogen, there are 2 atoms of nitrogen, so it is 28. And for oxygen, there are 6 atoms of oxygen, and the mass for 6 atoms of oxygen is 96. And total formula mass is 164. Clear? For copper sulfate crystals, the elements are copper, sulfur, oxygen, hydrogen, and again oxygen. So you have to use the atomic masses of copper, sulfur, oxygen, and hydrogen. This dot 5 is showing that there are 5 molecules of water. It is a hydrated compound, and there are 5 water molecules bonded to each copper sulfate molecule. It does not mean multiply, but there are 5 water molecules, right? So you have to add these water molecules as well. So 1 atom of copper 64, 1 atom of sulfur 32, 9 atoms of oxygen 4 plus 9 144, 10 atoms of hydrogen 5 multiplied to 10, and the final answer is 250, right? So this is how first you have to identify the elements that are present in any compound, in any formula. Either it is covalent compound or ionic compound. Then by using the periodic table, you can write down the atomic masses, relative atomic masses of the given elements, and then you have to multiply the relative atomic masses of the elements with the number of atoms, right? As the number of atom in this compound of oxygen are 9, so you have to multiply the relative atomic mass of oxygen with 9 and you will get the answer 144. Clear? Next is your test yourself 9.1 and 9.2 that you people have not done properly, so you have to note down the answers. For potassium hydroxide it was 56. You have to use the relative atomic mass of potassium, oxygen and hydrogen. In this case, lead nitrate, it is 331. Lead, nitrogen and oxygen. This is ammonium phosphate, it's 96. Ammonium phosphate have elements nitrogen, hydrogen, phosphorus and oxygen. This is calcium sulfate. Dot 2H2O is showing that this is hydrated compound. Calcium, sulfur, oxygen, hydrogen and oxygen. C2H5COOCH3. It has elements carbon, hydrogen, oxygen and hydrogen and carbon again. And for the second question, you have to find out the sum of the relative atomic masses of 4 nitrogen atoms is equal to the relative formula mass of XO. What is X? Answer is calcium. You can use this technique to find out sum of relative atomic masses of 4 nitrogen atom. What is the mass of 1 nitrogen atom? It is 14. And for 4 it will be 56. Now you have to find out the X. You can just deduct the relative atomic mass of X from A and you will get the answer, that is 40, and your element is calcium. The atomic mass of calcium is 40 in periodic table. Okay, so it's all for today's lecture. Allah Hafiz.